everyone. I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now, I am going to explain about the introduction to diffraction. At the end of this lecture, the students will able to learn the difference between the interference and diffraction, and also they can understand the types of diffraction. Coming to the definition of diffraction, when the light is passing through a slit whose width is comparable to the wavelength of light, then the transmitted light contains alternate maxima and minima. That pattern is called a diffraction pattern and the phenomenon is called diffraction. Coming to the more basic definition of this one, the phenomenon of bending of light rays into the geometrical shadow of an obstacle is known as diffraction. Here, to demonstrate this one, we just take an example when there is no any obstacle, the light just passing through that one, and on the screen we can have some illumination. When there is some obstacle and at the sharp edges the light will bend, and on the screen the light, you can observe the light is penetrating into the geometrical shadow of an obstacle. So, coming to the more basic definition, the bending of light rays, the phenomenon of bending of light rays into the geometrical shadow of an obstacle is known as diffraction. And here we just get a doubt. In case of interference, also we observe the bright and dark bands, and in case of interference and diffraction, both the cases we are getting the bright and dark bands. Then what is the difference between these two patterns? The moment we observe the pattern, we can understand this is interference pattern and this is diffraction pattern. Coming to the differences between interference and diffraction, actually to produce the interference, two coherent waves are required. So, this is due to the superposition of two separate wave fronts or two coherent waves, whereas in case of diffraction only one wave is enough. Then we can observe the alternate maxima and minima on the screen. Actually, in case of interference pattern, all the bright bands have the uniform intensity, whereas in case of diffraction, the bright bands intensity gradually decreases from center to outward. There exists a central maximum, later first order, second order. We can observe this kind of pattern: central maximum, first order maximum, second order, etc. Anyhow, coming to the minimum intensity. The minimum intensity in case of interference, the dark bands are perfectly dark. Intensity I minimum is equal to 0. Whereas in case of diffraction, the intensity of the minimum is not 100% dark, not perfectly dark. And so these are the differences between interference and diffraction. Coming to a glance, to produce the interference pattern, two coherent waves are required, whereas to produce the diffraction pattern, only one wave is enough. And the maxima intensity of the maxima is constant in case of interference, whereas it decreases from center to outward. Dark bands are 100% dark in interference, whereas dark bands intensity is not 100% dark in case of diffraction. So, just observing the pattern, we can say this is interference pattern or this is diffraction pattern. And coming to the types of diffraction, there are actually two types of diffraction or two classes of diffraction. One is called Fresnel's class and second one is Fraunhofer class of diffraction. So, what do we mean by a Fresnel's diffraction? What do we mean by a Fraunhofer diffraction? So, in case of Fresnel's diffraction, say this is the source and it is the screen. The source and screen are kept at finite distance from the diffracting agent, that may be a slit or an aperture or an obstacle. Whereas in case of Fraunhofer diffraction, both the source and screen, this is the source and this is the screen, this source and screen are kept at infinite distance. Actually, how do we achieve this one? To achieve this kind of arrangement, we are introducing two lenses L1 and L2 in between the source and the slit, and in between the slit and the screen. By arranging this kind of two lenses, we can achieve the light rays are coming from infinity and they are going to meet at infinite distance in case of Fraunhofer diffraction. Simply, there are two types of diffraction, namely Fresnel's class of diffraction, another one is Fraunhofer class. Actually, in case of Fresnel's diffraction, the point source or the illuminating narrow slit, okay, it is used, whereas in case of Fraunhofer diffraction, the extended source at infinite distance is used. Whereas in case of Fresnel's diffraction, coming to the wavefront, it is spherical, wavefront is spherical or cylindrical, whereas in case of Fraunhofer diffraction, the wavefront, it is plane. So, plane wavefront is used in case of Fraunhofer diffraction, spherical or cylindrical wavefront is used in case of Fresnel's diffraction. And yeah, just now we discussed, the source and screen are kept at finite distance in case of Fresnel's diffraction, whereas in case of Fraunhofer diffraction, both the source and screen are kept at infinite distance from the obstacle, or else the single slit or double slit, whatever it may be, that is the diffracting agent. And whereas no lenses are used in case of Fresnel's diffraction, we need not use any kind of lens there, whereas in the Fraunhofer diffraction, the converging lenses are used. Already just now we have seen in this one, already two lenses, lens L1 and L2. One lens is kept in between the source and the slit, another lens is kept in between the slit and the screen. So, in that way lenses are used in this one. These are the two types of diffraction or two classes of diffraction. So, okay, actually in this article, this is actually the introduction to the diffraction or diffraction. So, what we discussed is differences between interference and diffraction. What are the differences between these two? Just observing the pattern, we can say this is interference pattern and this is diffraction pattern. And afterwards, what are the types of diffraction? So, two types of diffraction we have seen, Fresnel's class of diffraction and Fraunhofer class of diffraction. So, this is just introduction to the diffraction. Thank you.